Welcome back, students. So in the last lecture we saw what a chromatic polynomial is and what is the general form of a chromatic polynomial. So in this lecture what we will see is we take the example of a specific graph like this, okay, and I will try to derive the chromatic polynomial for this graph. So this is the graph A, B, C, D, E. This is the graph G. Now I will try to derive the PG lambda for this graph. So I take PG lambda in the general form. So I have 5 vertices here. So I'll need to write here A1 lambda C1 plus A2 lambda C2 plus A3 lambda C3 plus A4 lambda C4 plus A5 into lambda C5. So this is the general form as we saw earlier, but for 5 vertices. Now I have to find out the values for A1, A2, A3, A4, A5. Now the first thing we have to see here is, or observe in the graph is, we have at least 2 clicks here, A, B, C and A, C, D, which are having 3 as cardinality. So the click number is 3. So we know from the theorem that we have already seen that it has to be greater than or equal to 3 because we have a click of size 3, or the click number is 3 for this graph. That means at least we will need 3 colors to paint this graph, right? Which means if we select 1 color or 2 color, we will not get any possible ways to color the graph. So we can simply knock off these 2 terms from the expression because using 1 or 2 colors we cannot paint the graph. Now say I have selected 3 colors, okay. So I have selected 3 colors. How many ways can I paint this graph? I can apply these 3 colors for this 1, 2, 3 vertices in factorial 3 ways, right? So 3 colors can be used in factorial 3 ways. Now we have 2 vertices left out. I can use this color, which is for the vertex D, for painting the vertex B because they are non-adjacent. I cannot use any other color because all of them are adjacent. So I can use the same color as D in vertex B. Same reason we can use the color for vertex C in vertex E. There is only one way to do it. I cannot use any other color. So A3, the value becomes 1 into factorial 3, which is factorial 3. Okay, so I now get the value of A3. Now coming to A4, or if I have selected 4 colors, or have 4 available colors in the palette. Now I can paint all these 4 vertices A, B, C, D using these 4 colors, right? So how many ways it can be done? Factorial 4 ways, right? Now I can either use this color or I can use this color to paint E. So 2 ways, right? So 2 ways. So A4 will become 2 into factorial 4, okay? So I get the value of A4 now. Coming to A5, I have 5 vertices, I have 5 colors. Simple, I can do the coloring in factorial 5 ways, right? So now I have got the value for A5. What is the general expression now going to be, or the chromatic polynomial? So PG lambda now is equal to A3, which is factorial 3 into lambda C3 plus 2 into factorial 4 into lambda C4 plus factorial 5 into lambda C5. Now we have to slowly kind of simplify this expression and get the final value of the polynomial. So this is the way we can derive the chromatic polynomial. Again, as I mentioned in the last lecture also, for each of the graphs, there is a different way we can find the values of the coefficients A1, A2, A3, or if it is more, A1, A2, A3, A4, A5. And it is not a standard or fixed way we can do it. Each an individual graph, we have to treat it differently, and we have to find out the different logics to calculate the values of the coefficients A1, A2, A3, A4, A5 or more. Okay, so I will pause at this. In the next lecture, I will talk about the decomposition theorem in context of chromatic polynomials and how they can be used to derive chromatic polynomials for complex graphs. Thank you very much. Stay tuned.